Okay, so let's go ahead and get started. So you should be seeing on your screen now, you should see my desktop and where I'm showing XSEDE.org. XSEDE stands for Extreme Science and Engineering Discovery Environment. If any of you have heard of NPACI or TerraGrid before this, XSEDE is the successor to those. TerraGrid became XSEDE, and Packy became TerraGrid. So what is XSEDE? XSEDE is funded by the National Science Foundation, and what it actually supports is a collection of computational resources around the country that researchers inside the United States can get access to. So if you're affiliated with a research center or a university, now I'm assuming you're all Michigan related, but that's not necessarily the case. Um, but you are affiliated with what's necessary to be able to, get access to one of these things. So XSEDE has all these resources, and these resources include storage, compute, and people resources. There's actually, I'll show you later, something called extended collaborative support, which is a way where what you put in a proposal for is not for just CPU hours on a machine, but you put in so many person months to have an expert help you parallelize your code, scale your code, evaluate performance on Xeon Phi, GPUs, something like that. So you can actually get help from beyond the normal like user support. How do I do X? How do I do Y? But to like dig into your thing for up to a month, multiple months spread. I mean, it's kind of like contracting. So you kind of get awarded a contract of a person. So if you ask for one person month, you don't have to consume it all in 1 month. You can actually kind of spread it out over, the 1 year period that these allocations are good for. So that's what XSEDE is. So it's all these national resources. Now, notice it is NSF. That said, a very large fraction of the resources are for people who are not supported by NSF. So there's been this thing out there for a long time that you need to have an NSF grant to apply for XSEDE time. That's not true at all. Um, about half the resources go to non-NSF affiliated projects. So these would be NIH, which is funny because NSF and NIH normally don't cross paths, but NIH funded work as well as work funded by other organizations or there really isn't any requirement to be associated or funded by NSF or one of the traditional research funding providers. So it can be, startup work. Anything that's considered valuable public work will be evaluated and considered to be allowed on XSEDE. Now, how do you actually kind of get started with this stuff? The first place to get started is to go to XSEDE.org, and there's a bunch of different pieces of information here. There's user services with guides, and then there's different resources that are available, and there's education programs, there's training things that you can take. You might have actually seen emails from us before. We've hosted on-site XSEDE training before, and we will continue to do that. You don't need to be an XSEDE user to be able to attend those. You need to have an XSEDE portal account, which you can get for free to be able to log into the website. But the only reason to have that is so they can put your name down on the the registration form, so they know how many seats you're taking. So anybody can take those training things, whether you're using XSEDE or not, or if you've submitted a proposal or not. So there's all these different things here. So you kind of get started here. So the first thing you really want to do is you want to go to XSEDE.org and click sign in and create an account. To create an account first, this is your portal account, and this will pretty much be used to do everything. And it's pretty basic information, name, address, phone number, the usual stuff. And from this registration, then you can log into the portal. And once you can log into the portal, you can actually submit proposals. So I already have a portal account. So I'm going to go ahead and log in here. And this drops me into the XSEDE portal. And so from here, I can actually go to the user portal. Sorry, it doesn't drop you directly to the user portal. But it'll have information when you first log in here. It'll show any allocations and stuff you already have. But the big thing is being able to submit allocations. And so you just go to the allocations tab here and you say submit and review account. Now there's lots of information based on on the website for examples of proposals and stuff like that. But I'm going to jump straight into the submit and review allocation because it has these kind of nice little charts here. There's 3 different types of allocations. The first one that pretty much everyone starts with is a startup allocation. Can't exceed 200,000 CPU hours. Each individual resource has their own limit though. So, while the total can't exceed 200,000, an individual resource may not let you request more than 30,000 or 100,000 hours. You can request hours on other resources, and I would encourage you to do that to, have a variety of resources to choose from, and there is a way to transfer hours between platforms. So if you requested a bunch of time to use Stampede with Xeon Phi and you find that, well, something Xeon Phi didn't actually work very well for me, I'd like to transfer my time to Gordon, which is just a CPU resource, a lot like Flux, a Sandy Bridge based, you can do that. So submissions are open year-round. That is, you'd submit this right now. And the allocations begin 2 to 3 weeks after submission. So what does this really mean? Startup allocations, they require minimal information to submit. It's pretty much a CV and an abstract, the resources you want, any supporting grants. They do want to track supporting grants, even though they're not required. And they're pretty much awarded on a regular basis. So within 2 or 3 weeks, you're generally up and running. I've never seen startups rejected. As long as you've got an abstract of the type of scientific work you're doing that's of reasonable quality, startups pretty much will get accepted. Then there's educational. For those of you who teach or are participating in a course where you would find HPC resources to be handy, you can actually get educational allocations. These pretty much work just like startups, except you can have multiples of these. So if you're teaching 2 different semesters, you can get 2 different, education grants to be able to do allocations. These are pretty straightforward. You upload your CV, the PI uploads a CV, or you can have your graduate student do it. And you pretty much say, I want, 100,000 hours on Stampede to teach, unstable mixing of fluids of 2 densities, or something like that, for a graduate level CFD course, or for an undergrad structures course, or something like that, where you want to use these resources, and they pretty much grant these right away. The only thing we run into issue here is that it takes 2 to 3 weeks for it to get set up, and then your students also have to get accounts and be added to it, and that takes a couple of days. So you want to kind of start the process for this, a month before you're going to use the resources. So, the end, before the semester starts, kind of submit a proposal of what you're going to be doing. And then the first day of class, tell students to come get a portal account and to send them your portal username so you can add them to your allocation. I've also, a lot of times for these, come to class to kind of give users a tutorial of how to kind of log in, submit jobs, and stuff like that. And I'm always available for that, whether it's for Flux, XSEDE, or other things like that. Oh yeah, by the way, I encourage you Friday to come to the user meeting. I put that into the chat box down here. That is tomorrow from 1 to 5 p.m. A bunch of the support staff for Flux and HPC for all the campuses will be in the LSA building in room 2001, LSA, and it's basically like open office hours. Come, bring your problem, bring what you're trying to do. We'll tell you things we know about that maybe you didn't know about, help you with PBS scripts, moving data, compiling code, how to use a GPU, anything you possibly want to know. Drop by. We'd love to hear what you're doing, and possibly, cross-pollinate information. So I encourage you to come Friday to that in 2001 LSA anytime between 1 and 5. There will be a meeting in July on the medical school campus. We'll watch for an announcement for when that is. Okay, so back to the allocation. So we have startups, which is what most people start with for research. Then we have educational, which you can use for teaching courses. And I have about 4 or 5 faculty who do this. It's pretty easy to get access to. Actually, it's trivially easy to get access to educational ones for teaching coursework. And then there's research allocations. Research allocations is kind of where you go after the startup. You can start filling out a research application at any time. There's windows that submissions are to be expected, and they're done 4 times a year. And you can see here the next one We are currently in the June to July window. So if you want to submit a research proposal to be able to start running October 1st, it needs to be in by July 15th. So these are only done 4 times a year. But when you do a research proposal, you can ask for any number of hours. They only last for a year. All of these things only last 1 year. So you can find yourself going through this process on an annual basis. So you're like, well, that's no good. I mean, normal grants last 5 years, something like that. True. Here's the thing about XSEDE allocations, though. Almost all of them get an award of some sort. Sometimes they won't give you as many CPU hours. Sometimes they won't necessarily give you the specific resource you asked for, because they only have so many resources to give out every quarter. But the majority of applications get some sort of award. Also, if you have a startup and you're burning through it very fast, you submit a research proposal, you can actually ask for an advance for some amount of the research proposal, so that when the research proposal, if it gets approved, that advance will be deducted from it. So if you're someone who consumes a lot of resources and you're going to be submitting a research proposal for a few million hours, and you're burning through your 200,000 very, very quickly, you can get an advance on your research proposal. Okay, so that's the 3 different allocation types. Is there any questions about those? Okay, so that's the 3 different allocation types. Now, how do you actually submit allocation requests? It's actually really easy. So once you're logged into the user portal and you come to the allocations, submit review allocations, you click this view, enter request. And then you can just say, submit a startup allocation, submit an education request. There's also these things called software test beds. I'm not going to touch on that. Submit research request. So it's actually pretty easy. You just click on this, and they'll walk you straight through. So you fill in, PI information that they're asking for, and you can actually save progress. You don't have to finish this all at once. Because one of the things, which is for the research proposals, you have to submit a couple of page document with benchmarking information and justification of the specific resource you're asking and the amount of time you're asking for. So that can be take a little time to put that in. So you can start filling all this in, and you can kind of come back to it and keep editing it. You don't have to do it all in one shot. Startup allocations, though, a lot of times I find I can fill it out within an hour or 2, and then in a couple of weeks I've got my 200,000 hours, and I'm kind of good to go. So everything's done online, everything's done through here, and you submit it all through that. Now, what do allocations look like? Well, there's a bunch of policies here you can read. And you can see it's a couple of pages long, but it'll generally touch on everything you need: new, renewal, supplemental allocation, transfer, extensions, and advance. So there's all the information about advancing and everything. So this is all in one thing, all one page. So they have other information here, types of proposals, and other information like foreign collaborators and for-profit organizations. So while this looks like a lot of pages, it covers literally everything you need. The other thing you can do is they have examples. They have recorded webinars of writing a successful allocation proposal, and they also have examples of good allocation proposals. So they have a couple of different examples here of the different types. And so this is all, again, log into the portal with your free account and look under successful requests. So those are your different allocation types and limits. So what are the actual limits, though? Well, okay, let's go over here to the resources and look at the system monitor. And these are kind of the different resources that are available. And as you can see, the size of the machines vary greatly in terms of performance and memory and other characteristics. And there is a resource catalog. So if you go to the actual XSEDE.org website, there is, right here, high performance computing, high throughput computing, and visualization. If you go to high performance computing, which is probably the one you're most interested in, they have dedicated user guides here for all of the major resources. So Blacklight, large shared memory machine. Darter is a new Cray system. Gordon, traditional machine that looks a lot like Flux, InfiniBand, and Sandy Bridge cores. Keeneland is a hybrid GPU-CPU system. Lone Star is going to be decommissioned, so I wouldn't recommend anybody new using Lone Star. Mason has machines that consist of a half a terabyte of memory each. Stampede is the biggest machine on XSEDE right now, which has a lot of normal Sandy Bridge cores and a lot of Xeon Phi accelerators and some GPUs. And Trestles is another traditional HPC system. So they have dedicated guides that have all the information you need, which has descriptions of the hardware. So you can see here, this is Blacklight at Pittsburgh Supercomputing Center. It has 4,096 cores and 128 gigabytes per 16 cores. So this works into 32 terabytes and it's divided in half. So there's 16 terabytes of RAM per computer in Blacklight. Blacklight's a unique machine. If you need a lot of RAM for a shared memory application, Blacklight is the largest shared memory machine in the world at 16 terabytes per machine. The largest machine we have on Flux has only 1 terabyte. So, and it's very expensive. So, on XSEDE, you can get more memory. You can also use it, because it's a shared memory machine, if you have a threaded code, and you could run a 256 core threaded job on Blacklight, and it would work. And you can't even do that on a machine like Flux, because the memory is not all shared. So there's kind of unique resources here. What are some of the other unique resources that are available? Well, okay, so you might have heard of the Xeon Phi, which is an accelerator. It's kind of like Intel's answer to GPU computing. Some people find it easier to port their existing code over to Xeon Phi than to a GPU to get the speed up. And Stampede has many, many Phis on them. So this is a 10 petaflop machine, which is very large. This is a top 100 machine. It has 6,400 nodes. And large amount of memory and everything else. It's a very large machine, has a large number of these Xeon Phis, but can also be very useful for people doing regular CPU use too, because not all the machines have Xeon Phi. And it also has a decent number of GPUs if you want to do visualization and or CUDA programming also. So this is probably the major workhorse right now on XSEDE. So there's Keeneland, which is all GPUs. And there's also some other unique resources like high throughput computing. For those of you who have significant needs for parameter sweeps, that is, you have if you can divide your problem up into many small tasks that can run independently, Open Science Grid through XSEDE is very nice because only so many things can take advantage of, and there's a lot of resources here. It's not been uncommon for people to get a few thousand processors going at a time on OSG. But here's the thing, every one of those processors is independent. So you need to have something that you can break down into 1,000 single core jobs that run relatively short, because this is a grid, and so that means they're kind of running opportunistically. They're kind of running on spare cycles. It uses a system called Condor, and I can help you kind of move your stuff over to Condor. It's a lot like PBS, but it has a couple of features to support this distributed nature of being on other people's machines, data staging, and things like that. So we have a number of people who are using this successfully, and you can get a lot of resources off of Open Science Grid through XSEDE without much effort, as long as your code maps to this kind of model. So there's different resources here. We have high throughput computing, we have traditional HPC, we have HPC with accelerators, we use either GPUs or Xeon Phi. There's also visualization resources. There's machines like Maverick, which looks a lot like a traditional cluster, but it's set up with a bunch of NVIDIA K40s, which you can also use to run CUDA code, but it's set up to support remote visualization. Machines have a lot of memory. The codes are all set up. The visualization codes like Visit and ParaView are all set up to take advantage of the GPUs. And you can do accelerated remote desktop with GPUs using something called Virtual GL. And they have a nice little portal where they create everything for you. And so when you submit your startup allocation, think about all these things you might want to try to do. Because it's easier to ask for it in the first proposal than it is to kind of do a supplemental, though you can do supplementals. So, get your main computational resource. Get as much time as you can get on that. Then supplement up to your 200,000 hours, other resources that kind of map nicely, traditional HPC, stuff like that. And then maybe throw in some visualization. And then there's also storage resources, test beds. So you can read about these because these are kind of handled differently. Now, there's something called ECCS, which is called Extended Collaborative Support. When you get to the last page of submitting your allocation proposal, there is the last page is literally a page of, I want 100,000 hours on Stampede, I want 50,000 hours on Gordon, I want 2 months. And so extended collaborative support is really, you could say, a consulting service. You can request time of an expert to kind of really dig into what you're doing. There is a special program called Novel and Innovative Projects, which can make getting a lot of ECCS time a lot easier if you're like a non-traditional user of national scientific resources. Think humanities and social sciences, think business school and things like that are non-traditional users of these things. A lot of times they're starting from ground zero because there's no existing code bases or methods, but they have an idea of something they want to do. That would fall under something that the novel and innovative projects people would kind of latch onto as, hey, this is neat. This is something that's not been done before. Let's kind of dig into that. But that said, it's open to pretty much everybody. So that is extended collaborative support. So any questions before I continue? Okay, so quick summary kind of thing. XSEDE is a set of national resources around the country. They're very easy to get access to. They do require proposals, but the proposals are range from the very simple for education and startup to require more effort like research. But the really unique thing is that they generally get awarded something. So they're a very reliable resource to use for computational needs for research, because they're not like a normal grant where, like, you ask NSF for money and 1 in 12 gets funded. Here, it's more like 90-some% get some sort of award. So it's pretty much, if you go through the effort, you can get it. Now, and there's a bunch of different types of resources. So here's kind of some other things to think about when using this. How does XSEDE actually run these systems? Well, these systems are set up as traditional batch systems. You would have seen them before. I can help you kind of on-ramp. So if you get an award and you've got an entire lab full of people who are going to be using that award, because multiple users can use an allocation. So the PI submits the allocation request, or the research scientist kind of does it for them, or the grad student does it for them. And then they have that award. You can then add people to it so they can run jobs against it, a lot like a flux allocation, multiple users inside one bucket of resources. Every resource provider has their own limits in terms of how long jobs can run for and the number of CPUs you can ask for. But it works like a debit card. So you get 20,000 hours. If you're running 1,000 CPU jobs, well, you're only going to be able to run for 20 hours of total wall time, because then you would have used all your 20,000 hours. So you can do that sort of thing. It works like a debit card. If you're not running, you're not burning time. If you are running, you're burning time off your balance. But that also means is your jobs may queue. Now, how bad are these queues? Not that bad. I was testing a 480 core job on Gordon. And Gordon consists of about 12,000 processors. So I was asking for somewhere around 3% of the resources. I submitted that job, a 480 core job, started in under an hour. So there's generally resources available. I don't normally see things waiting very long to run. Modest-sized jobs generally get running very quickly. It's not guaranteed immediate access like Flux is for the standard use case, but the flexibility, the cost, the scale of the jobs you can run. Honestly, I see it as another tool you can have that you can use to kind of work between both. Use something like Flux as a development platform because you have immediate access and you can kind of quickly iterate stuff. And then throw your heavy work at XSEDE to run larger jobs and use up your time there where it doesn't burn up any startup funding or things like that or other types of funding sources you have. Use XSEDE to work with it. We also do some stuff to make sure you can interoperate between our systems. So if you go to arc.research, oh, actually, I don't know if they made this page up yet. But, we actually have documentation. Okay, here we go. We have documentation for using, we have actually a software module on Flux called XSEDE. And what does this actually do is it lets you be able to SSH from Flux to XSEDE machines and transfer files back and forth. XSEDE has a system called GSI, which is Grid Security Infrastructure, but what it does is it lets you get it acts like Kerberos, but you get a little certificate that you get by doing this MyProxy login with your portal username, and you put in your portal password, and then you can SSH using this GSI SSH to any of the XSEDE machines without needing a password. So that's how you do it, and you can also use this GSI SCP, and it works like normal SCP, and you can do it. It also supports Globus for transferring files back and forth. So, and we also support Globus Online, which if you've never used it before is great, because what this lets us do is you can go to globus.org and get a free account. I'm already logged in. And you say transfer files, and this is all in a web browser. On this side, I'm going to pick XSEDE. If I want to go to Blacklight, I put in XSEDE pound and then the machine name, and it has a list here. It's a huge list, and it's autocomplete. So if I type just XSEDE pound, here's all the different XSEDE machines. And I say continue, and this is going to take me to the XSEDE website, and I log in with my portal username and password. And because I have an award on Gordon, now I can see my home directory on, not Gordon, Blacklight. And I go over here and I put in umish pound flux. I put in my Flux username and password. I now see my Flux directory over here, and I can just choose directories and such to transfer between the two machines. And the cool thing about this is it emails me when it's done, and it goes over dedicated machines with 10 gig connections over internet too. So these transfers are a lot faster, they're more reliable, they deal with networks coming and going and machine reboots. So this is we do all this stuff to make it easy for users to be able to move data between Flux and Nix and the XSEDE resources. And we have the XSEDE module to make it easy to be able to log in from Flux login node and transfer files back and forth using traditional SCP, using GSI SCP. So we try to make it easy to be able to interoperate between the two. So you shouldn't necessarily think about only using one. You should actually kind of use both. So that's actually everything I had. Is there any questions before we wrap up? Okay, well, that's everything. You can always email me, and the best way to do that is to send it to hpc-support@umish.edu. You can ask me questions about XSEDE, Flux, any HPC needs that you have, send it to HPC support, and we're kind of the clearinghouse for taking care of everything related to research computing. Again, I encourage you all, as many of you, to come as possible to the office hours that are held tomorrow from 1 to 5 p.m. in 2001 LSA. There will be another session in July on the medical campus. Otherwise, that's everything I had, and thank you very much for your time.